choosing between the star and the snowflake schemas. The textbook typically calls this the star or the snowflake schema. I prefer to call it a layout because the word schema is already used in database technologies. This is just for clarification purposes. So if I call this a layout, that's what I'm talking about. So we have our facts, we have our dimensions. If we put them together, we're just going to put them together in some hodgepodge format. Of course not. We need to carefully consider the design of this and how the tables are going to relate to each other. And the most basic form of that is to put your fact dead center, right here in the middle of all of your information. This is where all of the majority of your data is going to be written to in your data warehouse, because that's what's going to change the most. You have transactions and sales occurring every single day. Now, you don't necessarily have changes to your customers every single day, so you put that in a dimension table as an offshoot. You don't necessarily have changes to dates every single day. I mean, of course, the date does change every single day, but you're not going to be changing your table much because you're going to have all your future dates in it. You're not necessarily going to be changing locations or geographies regularly. You're going to have all of that information stored. You know, Detroit, Michigan is going to stay Detroit, Michigan, so it's not going to change much. The products themselves might not change all that much. We're going to have the products or items tables that we're going to be selling. And then, of course, lastly, your staff isn't going to be changing all of that much. You know, John Doe is going to be staying John Doe. And just by looking at this, do you see where the idea of a star layout is coming from here? You can kind of draw it right here like this. Check it out, it makes a star. This is a typical data warehouse layout. Now, when we're talking about transactional databases, they're more normalized than this, right? There's a lot more tables, there's a lot more joins going on, they're broken out a lot more. Data warehouses, that's not the case. Because we've already chosen the most high-performing hardware possible, the data warehouse is going to be flatter because it's going to be doing mostly reads. We don't have a whole lot of write and update and delete operations going on. This is just going to be mostly read throughout the day. So flatter data warehouses are actually better for us in this case. So we get it. We've got a fact in the middle. We've got dimensions branching off of it. This looks like a star. Where does the snowflake come in? Well, the snowflake comes in when our dimensions themselves need a little bit more depth. For instance, let's take product. Sometimes we categorize our products into subcategories. So we'll have another table here, and we'll call this subcategory. And this will be something like furniture, groceries, clothes. You see the idea there? We've got subcategories going on in that case. And then maybe from there we could actually branch it out even more into larger categories, something like consumer staples, electronics, appliances. Perhaps down here in geographies we have state as a dimension. And then within that we have country as a dimension as well. This all starts branching info off. When we do it over here like this is starting to form what looks more like a snowflake. And that's okay too, because ultimately what happens now is we're going to get prompted with a question, which one's better, right? And it just depends. Obviously with a snowflake, we're going to have more joins happening here, and that can have performance implications. But we also like to have the flexibility and granularity of our dimensions, because maybe we want to see our facts at the highest possible level by category. And then we give our users the ability to drill down into subcategory and then further into product if they want. It just depends on what's going to work best in your environment. There's not one that is better or worse than the other. And of course we can see a real world example of it. We've already looked at a data warehouse in a previous nugget. Now let's actually examine the layout of it. I've got the virtual lab fired up. We're going to click into client nug, paste the password in and get signed in. And we'll fire up SSMS. And we'll get connected to SQL Nug 2. Let's go ahead and expand our databases. And then we're going to expand the data warehouse that we've already looked at. This time I'm going to expand database diagrams. I've already created this for you guys. Let's go ahead and right click on it and choose Modify. Now, just to clean up the screen a little bit, I'm going to hide the Object Explorer here. We can scroll up a little bit. So right away, you can tell that this is a star layout. We've got our sales fact table dead center, and joined off of it based on a series of keys. We have an employee table, a date table. Scrolling up a little bit, we've got the customer table, and down a little bit we have the city or geography table. This is the fact in the center, the dimensions is the offshoot. This is going to be our star layout. What the Microsoft engineers did when they designed this data warehouse, they decided that this was going to be the most optimal way to design their data warehouse. If, for instance, they had done something different with the geography, like the city table here, maybe they had branched it off into state over here and region over here, you could see how pretty quickly that would begin to resemble a snowflake layout. Or in this case, maybe a hybrid layout where only some of the dimensions are actually branching off of each other. In this nugget, we began applying our newly found knowledge of facts and dimensions into an appropriate layout for our data warehouse. I hope this has been informative for you, and I'd like to thank you for viewing.